Welcome and thank you for always joining us. We are looking at a flowchart that reads the flowchart below illustrates two industrial processes. We have Haber process that manufactures ammonia on large scale. We also have contact process that manufactures sulfuric 6 acid. The flowchart begins from where we have air. And remember, air is a mixture of gases where we have carbon dioxide, we have water vapor, we have nitrogen, we have oxygen, and noble gases whose major component is argon. Before fractional distillation is carried out, carbon dioxide and water vapor are removed because the two readily solidify and would block the pipes. So we have air separating into nitrogen and oxygen through fractional distillation. So we are going to have nitrogen from air reacting with nitrogen to produce ammonia gas, and in this case the compound B which comes out of Haber process is ammonia, which is going to meet with sulfuric 6 acid that is moving from its production site. But before we can pick on that, let us go back and look at oxygen also, which is coming from air. Oxygen comes down to react with substance A to form sulfur 4 oxide. We have sulfur combining with oxygen to form sulfur 4 oxide, meaning compound A is sulfur. Then we are going to have sulfur 4 oxide combining with more oxygen to form sulfur 6 oxide, which is going to be dissolved in concentrated sulfuric 6 acid from contact process. So here we are going to have concentrated sulfuric 6 acid, meaning sulfur 6 oxide gas is going to be dissolved in concentrated sulfuric 6 acid to form compound C, which is oleum. H2, we have H2, S2O7. Oleum is going to be diluted with water to form sulfuric 6 acid. So sulfuric 6 acid is going to go up to react with ammonia. So we are going to have ammonia reacting with sulfuric 6 acid to produce ammonium sulfate. We can now move down and answer the questions. Roman 1, give the name of the process by which air is separated into oxygen and nitrogen. The process is fractional distillation. Fractional distillation. We move down. Apart from oxygen and nitrogen gases produced from process in A Roman 1 above, name one other gas produced. The other gas produced is argon from noble gases. B, name the substances represented by letters A. We have B, we have C and D. Let us look at A. A is sulfur. We have B. We have B. We have substance B, which is ammonia. We have ammonia gas. C is oleum. That one has been worked out already. Then we have We have C, name the catalyst used in Haber process. We use ion catalyst. We also have contact process. In contact process, we use vanadium 5-oxide. We can also use platinum. Explain the role, that is part D. Explain the role of the catalyst in both Haber process and contact process. Catalysts increase. They increase surface area for maximum yield. Of ammonia and concentrated sulfuric 6 acid. Let me use the symbols because of the interest of space. E, write a chemical equation for the formation of compound B. B is ammonia. So we are going to have nitrogen gas combining with hydrogen to produce NH3, which is ammonia gas. To balance the equation, we write 2 behind ammonia and of course 3 behind hydrogen. F, calculate the percentage by mass of nitrogen present in the compound. In this case, we are going to look at the compound produced, which is compound D. Let me look at compound D. Compound D is ammonium sulfate, and ammonium sulfate is going to be produced by reacting ammonia gas plus concentrated sulfuric 6 acid, which gives us ammonium sulfate. This can be a solid or in aqueous form because all ammonium salts are soluble. So we can balance the equation by writing 2 behind ammonia. So in that regard, we are supposed to calculate the percentage of nitrogen in ammonium sulfate. So the molar mass of ammonium sulfate is going to be equal to the sum of all the relative atomic masses of the elements forming ammonium sulfate, which is going to give us a total of 132. From there, to get the percentage of nitrogen, we look at the mass of nitrogen in this compound. Of course, nitrogen has a RAM of 14, you multiply by 2, you get 28, divided by the total mass of the compound D, you multiply by 100%, and this one is going to give us exactly 21.21%. Then the last part, which is G, give one major use of compound E. Compound E is a fertilizer, and therefore compound E is used as a nitrogenous fertilizer. And I want to assume this is not compound E but compound D. Thank you for watching and welcome to our discussions. And in case you're watching this channel for the first time, please take a second or two to click the subscribe button so that anytime we produce a video like this, you will automatically be given a notification. So for online classes, you can contact us on 0701 686 283.